The diagram below represents the graphs of the following. F of x equals minus 2x squared plus 8x plus 10, and g of x equals minus 2x minus 2. Determine the coordinates of A, which is the turning point. There's two ways you could do this. There are actually more, but we'll just keep it to two. You could do the x is equal to minus b over 2a method. And in this case, you will have minus, the b value is 8, divided by 2, and the a value is negative 2. So that's negative 8 divided by negative 2, which is, negative 8 divided by negative 4, which is 2. And so the y value is then going to be minus 2 into 2 squared plus 8 times 2 plus 10. That is 2 times 4, which is 8, so a negative 8, plus 16 plus 10, and that's 18. So the coordinate would be 2 and 18. Of course, the other method would be to complete the square. You can complete the square like this. You'll take out negative 2 as a factor. You'll be left with x squared minus 4x. You close the bracket and then add 10. Now in this bracket, you want to add and you want to subtract half of this negative 4 and then square it. So negative 2 into x squared minus 4x, and then half of negative 4 is negative 2, and then negative 2 squared is 4. So you'll add 4, you'll subtract 4, and then you'll add the 10 outside. Now you'll complete this. So negative 2, and then that can be factorized as x minus 2 all squared. Then you'll have your plus 10. And then this negative 4, you multiply by the negative 2 to take it outside the bracket. So negative 2 times negative 4 is plus 8. And so negative 2 into x minus 2 all squared plus 18. You can get your coordinates from here. So x minus 2 is equal to 0, x is equal to 2, and then y is equal to 18. So the coordinate is 2 and 18. Both methods would work. Next question, calculate the coordinates of B and C. So B and C are the x intercepts. So to solve for the x-intercepts, you make y 0. So minus 2x squared plus 8x plus 10 is equal to 0. Divide everything by negative 2, just to simplify it a bit. So that's going to be x squared minus 4x minus 5 equals 0. We can factorize as x minus 5, x plus 1. Then use the 0 factor rule. X is then equal to 5, or x is equal to negative 1. So they want B and C. So B will be 5 and 0. C will be negative 1 and 0. Next question says calculate the coordinate, or the coordinates of R. So R is the point of intersection between the two functions. So to solve for point of intersection, just equate the functions. So minus 2x squared plus 8x plus 10 equals minus 2x minus 2. So we want to add 2x to both sides. So this will cancel. Then we want to add 2 to both sides. So that would cancel. And so we'll be left with minus 2x squared plus 10x plus 12 equals 0. Now we'll divide by negative 2 again. So we'll have x squared minus 5x plus 10. That's negative 6 is equal to 0. Factorize x minus 6, x plus 1 equals 0. 0 factor rule, x is then equal to 6, or x is equal to negative 1. So r is sitting on the positive side of the x-axis. So r is going to be 6. And we actually need to figure out the coordinate, the y value. So to solve for the y value, sub it into either one of the equations. Let's sub it into the g of x. So g of x is equal to minus 2 times 6 minus 2. So that's negative 12 minus 2, negative 14. So the coordinate is 6 and negative 14. Question 7.2, if OD is equal to 1 unit, determine the length of PQ. So if OD is 1 unit, it means that the x value for P is going to be 1, and also the x value for Q will be 1, since that line is parallel to the y-axis. So we will say that since we want the length, we will subtract the two functions. So we will say minus 2x squared plus 8x plus 10, and we want to minus, so minus 2x minus 2, but since we want to minus it, that becomes a plus and that becomes a plus. So you're going to be left with minus 2x squared plus 10x plus 12. And that's going to be equal to our length PQ. Now we know the x value, it's 1, so we substitute 1 in. So minus 2 times 1 squared plus 10 times 1 plus 12, and that's equal to the length of PQ. So minus 2 plus 10 plus 12 is equal to 20, and that's PQ. It's 20 units. Question 7.3, determine the average gradient of the parabola between B and R. So gradient, well, average gradient. Still use the same formula though. It's equal to y2 minus y1 over x2 minus x1. So B was 0 and 5. And then R, what was the value for R? So R was 6 and negative 14. So that's equal to 14 over negative 1, which is negative 14. Question 7.4. For what values of f times g is greater than or equal to 0? So what we want to do here is we want to look at the functions. So f of x times g of x is greater than or equal to 0. So that can happen when f of x and g of x is negative, so you will get a positive answer, or when both of them are positive, you will get a positive answer. So let's separate this and evaluate. So I'm going to use the intercepts as my guide, and now let's use a color to mark it. So I'm going to use a highlighter to highlight where f of x is positive. So f of x is positive here, and I'll use green for where f of x is negative. So it's negative there and it's negative there. Then let's use purple for where g of x is positive. So g of x is positive there. And I will use blue for where g of x is negative. So it's negative here and here. Now let's color code this. So g of x is negative, and that's blue. Okay, so what we want to look for on our side, g of x, f of x, okay. So where are they going to be positive and where are they going to be negative, and then how can we decide? So we are looking for where they are both positive. So where are they both positive? they are not both positive in the same region. So that's out of the question. But where are they both negative? They are both negative this way, beyond that point. So we can state that x must be greater than or equal to 5. Now there's also an extra solution here. Since we're technically looking for where it's also equal to 0, we also should consider this point, because both of them are 0 there, and so 0 times 0 will be 0. So we'll say that x is also equal to -1. So x is equal to -1, and x is greater than or equal to 5.